So in this video, we're going to do the Holt Winters Additive Seasonal model. We're going to add seasonality to what we did with the Holt's Linear Trend Exponential Smoothing. So I'm going to move or copy, create a copy of this. We'll call this HWAS, or Holt Winters Additive Seasonal. We're going to add a column before E and call this Seasonal. We're going to drag down MSE and MAPE. And we'll have gamma is equal to 1. Or actually, let's change all these to 0.25. So now we've got 3 parameters. Let's delete what's happening in these first 4. So from C2 to F5, I'm going to delete that and put in the following information. So beginning in C5, the formula will be the average of those sales. The actual forecast in C6 will be I1 times, this will now be parentheses B6 minus E2 plus 1 minus I1 times C5 plus D5. So that's the modification. I'll double click with the black cross, send that down. And D5 trend to 0. The actual function, we'll change that to be I2 times C6 minus C5 plus 1 minus I2 times D5. It's not going to change, so that can stay the same. For seasonal, we need to see what the seasonal outputs are per year, and that's kind of what we're referencing to get at the seasonality. So that's going to be equal to, in cell E2, that'll be equal to B2 minus C5 anchored. And we'll drag that down. So that'll be our reference point. So our function will be equal I3 anchored times the difference between B6 and C6 plus 1 minus I anchored, I3 anchored, times E2. We'll double click with the black cross and send that down. The forecast, we will edit that to now include the seasonal from that particular month a year prior. So E2, and we'll use the black cross, send that down. Modifying MSE, we can, this now needs to be from B6 to B32, and now F6 to F32. And you can already see that this is just randomly picking numbers. This is already better than what we had previously. So now let's use Solver to get even better. So we're going to change this. Now I2 is I3 everywhere, since we have 3 parameters. Click OK. And then we're going to solve. So you should get 4.67% is your error. Gamma's 1, beta's 0.35, and alpha's 0.51. You can see that much better fit. Not perfect, but a lot better. And then at the bottom here, if we wanted to do some forecasts, we'll change this appropriately. So this will be the following. It'll be equal to C32 anchored plus D32 anchored times parentheses the row function minus row of F32 anchored. So parentheses plus E29. Hit enter. So we can forecast those values for June to March of 2020.